So we have question 2, which is under bond valuation. So we have Artemis 3 PLC has issued a 5-year bond with the following features. We have the face value of par value 1000. So the face value of par value is always 1000. The coupon rate we have been told is 10% per annum. So we can find the coupon amount by just saying 10% of the par value, which is 100 kwacha. Then coupon payments paid annually. So this coupon payment is paid annually each year. So since the bond is for 5 years, each year is going to be paid for 5 years. Current market price is 950. This is the market price of the bond. Required rate of return or discount rate 12%. What are we required to do? A. Calculate the value of the bond using the required rate of return of 12%. Based on your answer, determine whether the bond is overvalued or undervalued. Okay, so we can find the value of the bond using the formula for the value of the bond. Then when it comes to making the decision, we are going to check if what we are going to find is going to be bigger than 950, meaning the bond is undervalued. If what we are going to find is smaller than 950, meaning the bond is overvalued because the market price is bigger than what we have found. Okay. So question A, the value of the bond. In simpler term, it's given by the present value of the coupon payments, then plus the present value of the maturity value. So present value of the coupon payments, so present value of coupon payments plus the present value of the maturity value. So that's how we find the value of the bond. So now what is our coupon payment? In the question we were told that the coupon rate it's 10%, so we are finding 10% of the par value. So our par value is 1000. 10% of 1000, you'll find that it's 100 kwacha. So let me just show it here. So we are saying 10% of 1000 is just going to give us 100 kwacha. So this is our coupon payment. Okay, so the formula, how can we write this? So we are saying present value of the coupon payment. So what is our coupon payment? I can just use I. Then we can use the table where we can just get the discounting factor. So which table are we using? We are using the table for present value interest factor annuity, since this one is going to be paid continuously for 5 years. So yeah, we can use the table that has present value interest factor annuity. So present value interest factor annuity, at what percentage? The required is 12%. Then for how long? It's going for 5 years. Okay, then the present value of the maturity value. So maturity value is the same as the par value. The maturity value of bonds is always 1000. So to find the present value, we have to multiply it. So the maturity value is only paid at the end. So the table that we are going to use is just present value interest factor, no annuity, since it's only the once, but this one it's yearly, that's why we are using annuity. So at 12%, then 5 years. Okay, so we can do that. So what's our coupon payment? Our coupon payment is 100. What's our present value interest factor? So let me just show you the tables where we are getting this, of which in the exam the tables are attached to the questions paper. So this is the table. The table has actually 4 tables. There's table A1, A2, A3 up to A4. So A1 has future value interest factor. That's not the one we are looking for. A2 has future value interest factor annuity. That's not the one we are looking for. We can go to table A3. Table A3 has present value interest factor. That's not what we are looking for. Then we go to table A4. So table A4 has present value interest factor annuity. So this is the one that we are looking for. So we'll check for 12% where it's meeting with period 5. So when we go on our left side, we have the periods here. You have period 1, 2, 3, 4, 5. So you have to check for a percent where it's meeting with the period. So in this case, it's meeting at 3.6048 where I circled. So this is our present value interest factor annuity. But if you want, you can also use the formula to find the same one, 3.6048. So the formula for the discounting factor, the present value interest factor, is given by this. So that's the formula. So K just stands for the rate, which is 12%. So you can just say 1 minus this fraction, then we divide everything by K. Okay. So let's go and put our present value interest factor so that we can find. Okay, so we found what is in the table. We can just insert it here. We said it's 3.6048, then plus maturity value is always 1000. Present value interest factor is there in the table also, not the one that we did, but the other one that was on top. So we are checking for 12% at 5 years. We will find that there is 0.5674. Okay, so I can multiply this side. It's giving me 360.48 plus this side. When I multiply, it's giving me 567.4. So I can add the two, then it's giving me 927.88. So this is the value of the bond, or the true value of the bond. So the question was asking us to comment, so we can say something about this. What have we noticed? What we have found is 927. Then on the market it was saying 950. So meaning this bond is overvalued because the market price is so big than the actual. So we are going to say the bond is overvalued because the market price is greater than 927.88, which is the true value of the bond, which is the true value of the bond, true value of the bond. Okay, so the bond is overvalued because the market price of 950 is greater than 927, which is the true value of the bond. So we are done. B, estimate the bonds due to maturity using trial and error or interpolation method to compare the yield to maturity with the required rate of return and interpret the results. Okay. So we are going to use the formula for finding the yield to maturity. Then for the interpretation of the results, if the yield to maturity is going to be less than the required, if it's going to be less than 12%, then it just means that this bond is overvalued. If it's less than, then the bond is undervalued. So let's do that. We find the yield to maturity, we try to compare with the required rate of return. So for the trial and error method, like the way the question is saying here, we just have to be trying. It's just guesswork. Someone can use different figures depending on what they like, and someone else will also use different figures depending on what they like. Okay, so for the yield to maturity, when you are doing the interpolation formula in short, so we have the lowest rate plus the present value at lowest rate. So present value at the lowest rate minus the market price. Then we divide this with present value at lowest rate minus the present value at the highest rate. Okay, so we can put all that in brackets. Then here we have to multiply with this component, which is highest rate minus lowest rate. Okay, so what are we trying to say? Yield to maturity is given by this lowest rate, present value at the lowest rate, market price. So looking at the formula, we need a lot of things. We need to find the lowest rate, we need to find the highest rate and their present values. Okay, so now how do you know which one can you choose to be your lowest rate, which one can you choose to be your highest rate? So normally the highest rate, it gives a smaller percent, the highest rate gives a smaller present value. So in this case we are lucky. When I say present value, we are just trying to find the value of the bond using the rates that we have. So when you check in the first question, we found our value of the bond, which we can call present value if we want. When we used 12%, it was 927. It's below the market price. So we can use 12% as our highest rate, because what I said is that the highest rate, it's going to give you a smaller value of the bond than the market price. Then when you use a lowest rate, it's going to give you a bigger value of the bond than the market price. Okay, so meaning here we can keep, we have our highest rate, it's 12%. Then the present value at the highest rate, we are going to use 927.88. So what am I saying? What I'm saying is that we already have our highest rate, which is 12%, and the present value at highest rate we have is 927.88. So what we are now going to do is to find the lowest rate. So it's try and error. You can try to choose any percentage of your choice. So for me, let's try to use 11% and see what we are going to get if the value of the bond is going to be bigger than the market price. Okay, so we can find the value of the bond using 11%. What is the formula? So the formula, we said value of the bond is present value interest factor annuity 11% for 5 years plus the maturity value present value interest factor at 11% for 5 years. Okay, so what is the value of the bond? The coupon payment here, it's 100. Then when we go on our table for present value interest factor annuity, we check 11% in 5 years. What I have is 3.6959 plus the maturity value is always 1000. Present value interest factor at 11%, it's 0.5935. Okay, so when I punch here, what am I getting? This is giving me 369.59. Then here it's giving me 593.5. So when I add these two, the value of the bond is giving me 963.09. So what have we noticed? This is bingo. Good, this is what we want. It has passed. We actually have a bigger amount than the market price. Okay, so what can we say? In this case, we can say that our lowest rate, which I said gives a bigger value than the market price, is 11%. Then the present value at the lowest rate, we have 963.09. So since we have all the four things that we want, we can now put it in our interpolation formula there. Okay, so let me just write here, our yield to maturity is now going to be, what is our lowest rate? It's 11%. So I'm putting 11%, then plus what is the present value at the lowest rate? We have 963.09. The market rate is 950. Then we are dividing with present value at the lowest rate, 963.09, minus present value at the highest rate, it was 927.88. So we can put 927.88. Okay, then we said all this is supposed to be multiplied by highest rate minus lowest rate. So our highest is 12%, our lowest is 11%. Then we cross. Okay, so I can do everything that on top here. So what am I going to have? I'll have 11%, then plus here. When I subtract on top and divide, it's giving me 13.09. Then what is down when I subtract, it's giving me 35.21. Okay, then I can multiply all this with this one. 12 minus 11 is just giving us 1%. Okay, so we can divide this and multiply by 1. So when I do that, it's just giving me 11.4% as our yield to maturity. So that's what we do for the interpolation. So just a quick recap, we say the interpolation yield to maturity is just a try and error. This is the formula. You need to come up with the lowest rate and the highest rate. So for the highest rate, I said it gives the value of the bond which is less than the market price. So we're like, okay, we are lucky because we already have the value of the bond that is less than the market price. And which percentage did we use? We used 12%. So that's our highest rate, and this one is going to become our present value at the highest rate. Then we went to the lowest rate. The lowest rate, I said, it gives the present value that is bigger than the market price. So we tried to say, okay, let's try 11%. So when we tried 11%, we saw that we found 963 as the value of the bond. Yeah, then we just replace what we have in our formula. We can find our yield to maturity, which is 11.4%. The next question, they are asking us to calculate the maturity duration and the modified duration of the bond using the yield to maturity obtained in part B. So let's do that and see what we are going to get. So question C, they're asking us to find maturity duration, of which I can denote by MC. So this is given by sum of I multiply with the present value of the cash flows that I have. Okay, so this is the formula for maturity duration. It will make more sense when I do the table. Then all this I divide with the price of the bond, of which you know the current price of the bond is 950 on the market. Okay, so I need the table. It's going to start with here. So we have 1, 2, 3, 4, 5. Then the cash flows. So which cash flows do we have? We have been told that we have a coupon payment which is made annually. So we have 100 for year 1, 100 for year 2, 100 for year 3, 100 for year 4. But in year 5 we are going to have 2 cash flows. So since our bond is maturing after 5 years, so we have the maturity value which is 1000 and the coupon payment that we are supposed to receive in year 5. So we have 1100. So when I add the 2, it's going to be 1100. Then we can find the present value of these cash flows. So present value is just given by cash flow T. We divide by 1 plus R to the power T. So T just stands the number of the cash flow. So for example, I can get the first cash flow. I'll say 100 over 1 plus. So here the rate that we are using is the one from yield to maturity. which is 11.4%, the one we found in question B. So we can just put as 0.114 in terms of decimal point to the power 1. So we are going to realize that the present value for the first one, when I add what is down, I set to power 1, I divide into 100, it's giving me 89.7660682. Then I do the same to the second one, 100 over 1.0114 to the power 2. Here I'll put 2. What I'm getting is 80.88043. The other one is giving me 72.33432. The other one is giving me 64.93 20682. Then the other one, the last one, is giving me 641.16045. So what is the next step? Now we multiply these by the years so that we can have what's on top, year times present value. So this by 1, this by second year, this by third, this by fourth, then this by fifth. What values are we going to have? So here I'm still getting the same one. Then here I'm getting 161.76086. Then here I'm getting 217.00286. Then here I'm getting 259.72,731. Then here it's giving me 3,205.80225. So we now have year times present value of cash flows, but we want sum, so I can add all these to come up with the sum. So this is 3,205. So when I add everything, it's giving me 3,934.06095. So it means we now have what to put on top there, on top of our formula. So let's come up with Macaulay duration. So Macaulay duration. So what to put on top? We have 3934.06095. Then we divide by the price, the current market price of the bond, which is 950. So when I do that, it's giving me 4.141 years. So this is the Macaulay duration. Then I can go to modified duration. So how do you find modified duration? So modified duration is given by this formula. So we are going to say modified modified duration. It's given by Macaulay duration. Then we are dividing by 1 plus yield to maturity. So 1 plus yield to maturity. So what is Macaulay duration? We found what we have on top there. So it is 4.141. We are dividing with 1 plus yield to maturity is 11.4%, which is the same as this. Okay, so what do we get? So we can divide by 1.114. Okay, so it has given me 3.717, which is just the same as 3.72 years. Okay, so this is the modified duration. That's what we're supposed to do. Then for G, they are saying if interest rates increase to 14%, what happens to the bond value and duration? Back up your answer with computations. So let's try to find our new value of the bond using the same formula that we did in question A, but this time we are using 14%. And also we are going to calculate the duration, then we can explain. So for the value of the bond, we are using the same formula that we did in question A. How do we find the value of the bond? Okay, so value of the bond, we said it's given by the coupon payment, open brackets, present value, interest factor, annuity. Since coupon payments are paid per year, so this is an annuity. Now we are increasing the interest rate to 14%, so we are going to look for 14% for 5 years, then plus the maturity value of the bond. Here we multiply with the present value interest factor, just because this is only paid at the end of the bond. So 14% for 5 years. Okay, so what's our coupon payment? Our coupon payment is always constant because we said the coupon rate, we are told it's 10%, and it's calculated on the par value. So 10% of 1000 is going to be 100 kwacha. But for the present value interest factor, we go on our table, we look for 14% in period 5. What I'm finding is 3.4331, then plus our maturity value is 1000. What's the present value interest factor at 14% period 5? It's giving me 0.5194. So I can multiply what's this side, 343.31. Then this side, what are we finding? It's giving me 519.4. Okay, so when we do that, we can just add these two. We can find that the value of the bond is 862.71. So the question was asking us to comment what happens to the value of the bond after increasing the interest rate. So what have we noticed? The value of the bond has reduced very much. Okay, and if you remember when we were finding the yield to maturity, we said if you want to have a smaller value of the bond, just get a bigger percentage. So that's what has even happened here. After increasing the percentage, what we have is a smaller value of the bond. Okay, so here we can say the value of the bond reduces from the market, which is 950 to 862, or since it was at 12%, it was 927 for 12%, it's now reducing to this. So we can just say the value of the bond reduces from 927.88 at 12% to 862.71 at what percent did we use? At 14%. Yeah, that's all. Then they also asked us to comment on the duration. So because of time, you can finish for the duration. You know what to do. What did we do for finding the duration? So here is what you then for question E, explain why duration is important for interest rate risk. So here depends with how you research. This is theory. So I'm going to attach my answer.